Welcome to the project Programming a God. Today we will be solving the power sequence problem from Codeforces round 666 division 2. Let's look at its problem statement first. This is the problem statement. We are provided with an array. At the beginning we can arrange the array as we want. Now we can perform an operation on the array. In every operation we can either increase or decrease the value of an individual element by 1. We have to find the minimum operations it will take to transform the array into a power sequence. A power sequence means that every element must be equal to some value c raised to the index of that element. Example is 1, 2, 4, 8 and 16. Another example is 1, 3, 9 and 27. The input is number of elements and the array of n elements. Let's look at a sample case. We have an array of 3 numbers as shown. We can reorder the array into the following array. Now if we convert the third element, that is 7 to 9, then we get a power sequence of 3. To do this we first convert 7 to 8 and then 8 to 9. So the minimum cost of transformation is 2 and that's our answer. Let's see what thinking we need to solve this problem. In any power sequence the numbers are in ascending order, so it makes sense to sort the array first. Now we will work on the sorted array. This problem is a greedy problem and so we need the values of c that are possible. Minimum value can be 1. We can have a power sequence of 1. The maximum value can be 10 raised to 14. Any value larger than this might become too large and we may run out of bounds. So our answer should be within this range. Now we can run our loop within this range and find the cost for each value of c. The minimum cost will be our answer. We already have the sorted array. We need to get the minimum answer. So initially we can set answer as very large number. Also we will begin with c equal to 1. We will continue our loop till the values become too large. To store the cost for each value of c we will use variable cost. Also k is the value that the power sequence should have at the position I. At position 0 it will be 1. Now let's run the loop on the array. First we add the cost of converting the I element of array into k. Now we increase the value of k to the next element of power sequence. We also keep a check on value of k. If the value becomes too large then we set cost to 10 raised to 14 and break the loop. We also don't need to continue the loop if the cost becomes greater than the answer because we need the minimum cost. Now outside this for loop, we will use the value of cost as a flag. If the value is equal to 10 raised to 14, that means value of c is now going out of bounds and there is no point in continuing the loop. The value in our answer variable should be the minimum cost. If this is not the case then we change the value of answer to cost if cost is smaller than current answer. Next we increment c and continue the loop. This is all we need to do. The problem is very tricky. Next we have provided the C++ code for this. Please subscribe to support the channel.